start this. Here we go. Where's number 8? There's number 8. So I've got 7k minus 2, and then in brackets 3k plus 1, and then in brackets minus 9. So there are BEDMAS rules we need to follow here. It's similar to number 7. Number 8 goes like this. I want to make sure, so BEDMAS goes brackets, exponents, division, multiplication, addition, subtraction. We haven't looked at any division. There is no math to simplify in the brackets because there are no like terms in there. There's no exponents, so we're going to go straight to the multiplication. Gentlemen, we need to make sure that when we're multiplying, we take this monomial out front with the sign, that negative sign, and distribute it onto everything in the brackets. The brackets end right there. We're just multiplying the negative 2. That 7k is just positive out front. And so when we do that, what we're going to get is 7k. Nothing has happened to him yet, so we're just going to write it down. And then negative 2 times 3k is going to be negative. Negative 2 times 3 is negative 6. And nothing multiplies with the k, so it just comes along for the ride. Negative 2 times positive 1 is going to be minus 2. That's the multiplication done, and then this minus 9 is going to get tacked on at the end. So then 7, now we group our like terms. 7k minus 6k is just 1k, which I'll just write as the letter k. And then I've got a minus 2 minus 9. Negative 2 minus 9 is negative 11. So we're looking for k minus 11. There she is. Cool? Zara? Okay. Does anyone have any other questions from any part of the sheet? Yes. Number 12. 12 is similar. It's 8 plus 9x plus, and then it's 4 times 11 minus 2x. BEDMAS says we multiply. So I'm going to distribute this positive 4 into that set of brackets. Nothing has happened with the 8 plus 9x. It just comes along for the ride. Now, positive 4 times positive 11 is going to be positive 44. And then positive 4 times negative 2 is going to be negative 8, and the x comes along for the ride. I'm willing to bet some of you are trying to do too much in your head, and then that's where the mistakes are coming from. And now we're going to group our like terms. If you recall, like terms have to have the same letters, and those letters have to have the same exponents. So I've got x's here and x's here. I've got positive 9x's, and I've got negative 8x's. You have to include that sign out front. 9x minus 8x is just, if I group these two, that's just going to be x. And then 8 plus 44 is going to be 52. I'm going to get 52 plus x, or x plus 52. There it is. Josh, make sense? Okay. Does anyone want me to do any more of these off this page? Okay. Okie dokie. What should you not do if you want to help get rid of graffiti? I'll slide down here to the bottom. What you should not do if you want to get rid of graffiti is sign a partition. A partition is a wall. If you sign a wall, you are, committing graffiti. So if you want to get rid of graffiti, you should not write on the wall, is what that means. It's funny. So many of you are just rolling in laughter. Is there any questions on here that anyone would like me to do? These ones got more interesting because some of them had multiple sets of brackets inside. Are there any of these questions anyone would like me to do? Yes, Emerson. Number 12. 12's a gooder. Okay, so we're distributing and we're adding. If you take a look here, we've got in brackets 4x minus 9, close the bracket, plus 8, bracket 2x plus 3, close the bracket, minus 7x. Now, this set of brackets has nothing being multiplied onto it, so these ones we can just drop. We're going to get 4x minus 9. Now, on the second set, we have the plus 8, and then in brackets, the 2x plus 3. So this positive 8 is going to be multiplied onto the 2x and onto the 3. Positive 8 times 2x is going to be plus 16x. Positive 8 times positive 3 is positive 24. The bracket ends it for us, and then I've got a minus 7x there on the end. Now I want to gather our like terms. There's one, there's one, and there's one. I've got a 4x plus 16x minus 7x. 4x plus 16x is 20x minus 7x is 13x. Did I do that right? I think I did. 13x. Done, done, done. And I've got a negative 9 plus 24. Negative 9 plus 24 is going to be plus 15. So this one happens to be almost right beside it. There it is, letter I. Emerson, that makes sense? Number 11 is arguably, 13 is arguably worse. 13, you have to make sure that you distribute this minus sign in. On this one, you're going to get 11 minus 3x plus 6 plus, and then you have to distribute that 2 in to that set of brackets, plus 8x plus 10 minus x, and group your like terms and keep going. So these ones, the questions got slightly more involved. But again, if you're following along with the lessons I'm trying to give, you're doing the practice, like I don't think any of this is beyond any of you. You're allowed to use calculators at this stage if the multiplication is what's tripping you up. We forget what 8 times 3 is. You have a calculator for that. It's just making sure you follow the steps, being really deliberate about what gets distributed, and then putting in the practice for a whole bunch of you. That was part of what I wrote on the report card comments. You just need to be willing to spend the time to play with this stuff, and it will come. You'll figure it out. So that was that one. Is there any other ones anyone wants me to do? I mean, Emerson kind of picked some of the nastiest ones. Everything's easier than those ones. Okay. And then the last one, what did the Spanish farmer say to his chicken? The Spanish farmer said to his chicken, "Ole." Are there any of these questions anyone would like me to do? Comments, questions, concerns on any part of this page? Okay. Going once, twice, thrice, sold. Okay. So Thursday was just more practice of the same. Wednesday we looked at multiplying polynomials. Today we're going to look at dividing polynomials. I would like you to flip until you find this page. Lesson 6, dividing polynomials. Find that guy. Where am I here? Okay. Okay, here we go. So, multiplication and has been looked at. Let's take a look at division, and this will be the end of this chapter. So dividing polynomials. You can divide polynomials the same way we divide really anything. And if you recall what division actually means, which has been a struggle, I think, for a lot of my grade 9s this semester, the purpose of division, so if I had something like 8x squared, and I want to divide 8x squared by 2x, what I want to figure out is what times 2x is 8x squared. Like some of you will definitely be able to do this backwards and say, oh, well, because this times 2x is 8x squared, this is what 8x squared divided by 2x is. What I want you to be able to do, though, there's a method that I want you to be able to use because the questions are going to get that much more difficult. And unless you have a method that you can fall back on each time, you're going to get stuck. Some of these questions, like these simple ones here, this question looks just like something we did out of the exponent laws stuff. And the procedure is the same. So I'll just go through the steps, and then we'll do 2 examples, and I'll leave you to practice them. We can do another example if you want after that, but we'll do a couple examples and then move on. So first step, when you're doing division of polynomials, and what we're doing is we're dividing polynomials by a monomial. In grade 10, in grade 11, you're going to spend time dividing polynomials by other polynomials, larger objects. What you want to do when you're dividing polynomials by a monomial is you want to divide numbers by numbers. You want to include the coefficients, and you want to divide those just like we would divide, well, 8 divided by 2. Sometimes the division isn't totally complete. If the division's not totally complete, what we're going to end up doing is just reducing the fraction. Sometimes that's what the division actually looks like. We want to divide variables by variables. So it's looking at exponent rules and remembering that second rule. What happens when you have the same variable and you're dividing them? When dividing powers with the same base, in the case of, we're going to use variables for this, so what do we do with the exponents? Yeah, house and joke. We want to subtract the exponents, you bet. And when you're doing this, you want to make sure that you are dividing, when you are dividing a binomial or a trinomial, or however many terms there are, when this is what's in the numerator, what you need to make sure you do is that you divide each term with the monomial. You have to make, one of the mistakes I will see students make all the time is they'll just divide it out piece by piece. Or they'll say, oh, well, I've got a 2x here. I can divide just this 4 by that -2. That you cannot do. You need to make sure that every term gets divided properly. I'll show you how to set this up. Okay, so first example. It looks like it comes straight out of that exponents chapter. If I have 8x squared divided by 2x, again, the steps are we want to divide the coefficients and we want to divide the variables. And we want to make sure that every term in the numerator gets divided by the denominator. Now, I've only got one term in the numerator. I've got 8x squared. So what we're going to do is divide it piece by piece. What's 8 over 2? This just gives us 4. It divides cleanly. We're not reducing any fractions. It's just 4. And now what do I do with this piece? What is x squared over x? Well, when there is no exponent written, the exponent is a 1. So let's put the 1 in there. And now when I'm dividing, I subtract exponents. It's always top minus bottom. So I've got x squared divided by x to the 1. So 2 minus 1 is 1. So this is just going to be x to the power of 1. And so what this means is 8x squared divided by 2x is 4x. And we can go back and we can check this thing. We check our work by doing the multiplication. What is 2x times 4x? Well, multiplying monomials, we just multiplied the coefficients, and we multiplied the variables. 2 times 4 is 8. X times x is? I heard someone say x2 or x squared. So we can check our work by multiplying. Multiplying the solution, this thing, by the denominator. You multiply them back together, and if you get what you started with, this piece here is this piece here. If that happens, you're set. So there are ways to check it every time. For those of you who love to check your work on tests, you take twice as long because you do the question twice. Do it forwards, and then go back and do it backwards. Okay, monomial by a monomial, not so bad. Japrit, put your phone away. If I have to ask you again, I'm going to send it down to the office. I've started, did I tell you guys I started doing this? Yeah, I've started doing this now. Okay, so I've got, let's do another one. I've got 8x squared plus 4x, all divided by -2. What we need to make sure we do, again, is when you've got multiple terms in the numerator, we need to split this thing up. This is going to become this problem. We need to make sure that we divide each term in the numerator by what's going on in the denominator. So I'm going to rewrite this thing as 8x squared over -2 plus 4x over -2. Sorry, that's -2x. Rewrite it as every term in the numerator divided by the denominator. And now we're going to simplify these piece by piece just like we did the first question. Now these are just monomial divided by a monomial. So 8, and again, we go coefficient, coefficient, variable, variable. This piece, 8 divided by -2 is -4. And x squared divided by x is? It's just going to be x. Remember, it's the same as x squared over x to the 1. 2 minus 1 is 1. We don't have to write that 1 in the exponent. So this is just going to be -4x. And then this piece here, 4 divided by -2 is -2. So that negative becomes the sign in between, so it's going to be subtraction. So it's going to become -4x minus 2, and then x divided by x is 1. So this piece here is just 1. So it's going to be -2 times 1, which is just -2. So this then is the solution we should get when 8x squared plus 4x is divided by -2x. And we can check it. We can multiply this back together to check. I want to multiply this piece with our solution. We're going to take those, and if we get the numerator, we're done. So let's check it. I have -2x, and I'm going to multiply that back together with -4x minus 2. So we're going to distribute it in. We need to make sure we distribute it onto both terms. What is -2x times -4x? Well, -2 times -4 is 8, and x times x is x squared. Cool, that's the first term done. And I want to go -2x times -2. Well, -2 times -2 is +4 rather. And that x comes along for the ride. This is what we started with. So then this must be a totally valid solution. It's not going to get any worse, I don't think, than these. Let me double check what you've got coming at you. Nope, that's it. Yep, that's it. I could make it more interesting, like we could put brackets around things, Let's do one fun one. Do I want to do a fun one? Do I? Don't I? I'll do one more. I'll turn some of these into something slightly more interesting. Okay, so let's do one of these, a couple of these as examples. I'm going to take this question, it's negative 2x squared plus 15, and I'm going to change the question. What we're going to do is we're going to extend this fraction. I want you to add brackets around the numerator. And we're going to put, I don't know, let's put a 2 out front. So now what I've done here is I've changed the question. Instead of negative 25x squared plus 15 divided by 5, I have 2 times something in brackets in the numerator divided by 5. Should you see something like this, what you want to do is you want to simplify the numerator first. Numerator first. We can't divide inside these brackets until we've dealt with this guy here out front. So let's distribute that guy in. We'll start combining the skills that we've looked at. And what I'm going to get here, if I multiply that 2 in, 2 times negative 25 is negative 50 x squared. There's no x here to multiply with that x squared, so it just comes along for the ride. And then 2 times 15 is going to be positive 30. And we're dividing that whole thing by 5. So it's just 2 steps. This is what we did on Thursday plus what we're adding in here today. So I've distributed this in, and now I can treat the division here properly. I can rewrite this thing as each term in the numerator over the denominator. So it's going to be negative 50x squared divided by 5 plus 30 over 5. And now I can solve this thing piece by piece. Negative 50 divided by 5 is negative 10. If that doesn't come quickly to you, grab a calculator or your multiplication tables. And there is nothing to reduce the x or to simplify the x squared with. So it just comes along for the ride. Plus, and then 30 divided by 5 is 6. And we're done. It's just 2 steps instead of 1. And I'll leave it there. It doesn't matter how many terms you have in the numerator. The step is the same. So if I have 2 terms in the numerator, we broke it up. This one over the denominator and this one over the denominator. If you have 3 in the numerator, it's just going to be the same thing. This over this, this over this, and this over this. The procedure here is the same throughout. So this is it for today. This is it for the chapter, really. I want you guys to, we're going to make this more interesting after you've had some time to practice this. So you guys I want you to start here. I'd like you to do the rest of this page, and we'll see how far you get. I would like it if you guys could get to the end of page 10 today. It's only 8:45. You have lots of time to do this. There are answers at the bottom of page 10. If you can get to the end of that, that would be great. If you finish that, let me know. Yeah, this is it. End of the chapter. Take a look at that. Any market take giver? Yes, sir. Sean's found a mistake in the answer key. Number 5 shouldn't be 3x plus 3. Number 5 should be 9x plus 3. There, so I'll fix that. There you go.